We're going we're going to start looking at the periodic table and the different ways that we can classify parts of the periodic table for organization to better understand what's going on. First, we're going to look at the section of the periodic tables. So, and we are looking at column 1. So we're right here in this red area, and that is the alkali metals. And then we have family number 2, which is the second column of the periodic table, and that guy is in orange. So that is the alkaline earth metals. We also have a section in the middle from 3 through 12. Those are our transition metals. Remember, those guys can change. That's why they're called a transition, and we have spoken about those during bonding. The next area of the periodic table is not shaded in. They do not have particular names for those families or those columns because they're a hodgepodge of things. There are metals, nonmetals, and metalloids and transition metals in there, so that area does not have a specific name. And then we can go to column 17 over there in green. We have our halogen family, and we have column 18 there, or column 8, and that is our noble gas family. And then our last area of the periodic table that we did not address is this bottom section down here. Those are the intertransition metals, or the transuranic metals. So there's two different names for them. We also talk about that as being the F section of the periodic table. So those are the different families in the periodic table that we use to classify information. So let's look at the alkali metals. Alkali metals are group 1A, so above that column you see the Roman numeral 1 and A, also known as group 1. They are located in the S section of the periodic table. They are the most reactive metals. They have one valence electron, and they make a positive 1 ion or a cation with a +1 charge. So let's go back 1 second. And we are talking about that section that is right here. So that on your periodic table up here, there is a Roman numeral 1A or a 1, and they are a positive 1 ion. Our next group is the alkali earth metals, or alkaline earth metals. They are Roman numeral group 2A or group 2. They are also in the S section. They are reactive metals, but they are not as reactive as alkali metals. They have two valence electrons, and they make a positive 2 cation, or just a positive 2 ion, and it being positive, it is a cation. So let's look back quickly here. And I just want to point out when we're talking about the sections of the periodic table, we are referring to this area right here being the S section. This area over here is the P section. And then this area down here is D, and over here is the F section of the periodic table. So we're talking about different locations on the periodic table. All right, so moving back to alkali earth and then transition metals. Transition metals were the yellow area of the periodic table. They are in groups 3 through 12. They have B's after their Roman numerals, so they are the B columns of the periodic table. As shown earlier, they are the D section, and the number of valence electrons equals the Roman numeral above the group. Keep in mind they can change when they're forming ions or when they're bonding, so they can form more than one cation. So transition meaning change, they can form more than one cation. The P section was a little tricky. I said there was an area where there weren't really families. So we have group 13 is also Roman numeral 3A. There are 3 valence electrons and they create a positive 3 ion. Group 14 or group 4A has 4 valence electrons and they create a positive or negative 4 ion. Group 15 or group 5A has 5 valence electrons and they create a negative 3 ion. And group 16 or group 6A has 6 valence electrons and they create negative 2 ions. All of these columns of the periodic table, column 13, 14, 15, and 16, are part of the P section of the periodic table. And keep in mind, I did say they don't have an actual family name because there's a compilation of metals and nonmetals in there. And we also have different phases. We have some gases in there, so there aren't a lot of similarities within the row other than the types of ions that they can form. So they do contain transition metals. There's other things going on. The halogens was the green section of the periodic table, and they are group 17, Roman numeral 7A elements. They are also part of the P section of the periodic table. They are the most reactive nonmetals. There are 7 valence electrons, and they form negative ions, so -1 charge, and those make anions. So the green section is the halogens in column 7A or group 17 of the periodic table. The noble gases are group 18. They're the last column of the periodic table, or 8A. They are in the P section also. They are unreactive. They have 8 valence electrons, except helium has only 2 because he only has 2 electrons. The other elements try to be like them and they become ions when they do that. The inner transition metals, those were the guys way down at the bottom. We said they were the F section, and they are also, each row has a special name. The lanthanides are elements 58 to 71. They get their name because they attach to lanthanum. And then the actinides are numbers 90 through 103, and they get their name because they're attached to actinide, or actinium, sorry. Some other information that is important to know, besides just the simple family. We did say hydrogen is in group 1, even though it is a gas, so it's not exactly like everybody in his family because he's the only gas out of all of those. He's not a metal. Hydrogen's location is related to its valence electrons and not its properties. So the fact that it's a gas is not why it's over there. It's because it has 1 valence electron. Valence electrons are those electrons in the outermost energy level. They are the ones that are involved in bonding. And we have elements in a group have similar properties because they have the same number of valence electrons, so that's why they are families. And valence electrons also determine how reactive an atom is, so what types of things it's going to do. Another way we can look at the periodic table are the periods. So keep in mind, periods are going left to right. So we're talking about the horizontal part, whereas families were going up and down. So you can see on this periodic table, they're colored as you go across. But if you look at the periodic table in the front of the classroom, it's not quite like that. So that periodic table is to show something else, not necessarily periods. So periods, the elements in a period are not alike, so the elements that are going across left to right are not the same or exactly similar in properties. They can be completely different. We are talking about the horizontal rows. The number for the period represents the number of occupied energy levels. So how many rings would be around the nucleus for the location of the electrons? Period 1 has only 2 elements, so if you count across there, you see there's 2 blocks going across. Period 2 and 3 show 8 elements each, so if you count those, you have 2 on the left and you have 6 on the right. And periods 4 and 5 have 18 elements, so if you count straight across there, you have 2, then a section of 10, then a section of 6, giving you 18. And period 6 has 32 elements because technically the F section gets included there. The first element in each period has 1 electron in the outermost energy level. So when we look at that, they are all the same family, so that would make sense that the first element on the left would have 1 electron because its family has 1 valence electron. So if we think about that, period 1 we have hydrogen with 1 electron and it has a K shell or first energy level. Period 2 we're looking at lithium, has 1 electron in the second energy level or the L shell. And period 3 has 1 electron in the third energy level or the M shell. And period 4, potassium, has 1 electron in the fourth energy level or the N shell. So that keeps going on. So every element in the period as you go down has the same amount of electrons. And the first element in the period is usually an active solid. And the last element in the period is always an inactive gas. So as you go from left to right, you start with a very active solid, somebody who really wants to react with things. And then as you get to the right, you end up with those noble gases, and they are inactive. Some other things to look at here are metals, nonmetals, and metalloids. So you should color in your periodic table or have one where, excuse me, you are showing where your metals are, and your metals are throughout this section. So it may actually be easier to just find your metalloids, and they are starting right here with boron, and then you have that zigzag line and they go down. So those guys making the zigzag there are your metalloids. And then you have your nonmetals, so don't forget you have hydrogen here and helium, and then you're going down with the noble gases. So if you come over 1, 2, 3, 4, 5 blocks, then you could start coloring those in green, and as you go down each row, you would color in one less block. So there are those areas of metals, nonmetals, and metalloids, and we will talk about those. So a metal has luster or shine. It is a good conductor of heat and electricity, so that's why we use a lot of copper wiring for our houses. So your house's dielectric system is done by copper wiring. They are malleable and ductile, meaning we can bend them, mold them, flatten them out, hammer them out to get them smooth, or we can make wires. And the majority of the metals are solids at room temperature. There is only one metal that is not a solid, and that is mercury, and we'll talk about that again with phases or states of matter. The nonmetals, which are on the right side of the periodic table, they are the ones colored in green. The element that does not, or elements that do not, exhibit characteristics of a metal, so they're basically the anti-metal, the opposite. They are poor conductors of heat and electric current. They do have low boiling points. If you look at the periodic table, many of them are gases. They're indicated in red at room temperature, and then we have our liquid bromine and then a few solids. So the nonmetal section has many different states of matter at room temperature, whereas the metals, most of them are solids. Then the metalloids are our last section for that classification system. They are elements that are both metallic and non-metallic in characteristics, or a semi-metal. So if we think about silicon, it is a shiny gray crystal that conducts electricity. So it's extremely brittle, unlike a metal, but it does conduct electricity like a metal, and it has that shine and luster. The phases or states of the elements, we have solid, liquid, and gas, as well as there are some synthetics in there. So the ones to point out are bromine over here and mercury. We also have our man-made stuff, so these clear blocks, technetium, and then some guys over here. Those guys are man-made. Please note that most of the gases are over here with your noble gases, and then we have some more in column 17 and going across the top, as well as we have hydrogen there. So we do have some of those other states floating around in there, but keep in mind hydrogen can technically be over in column 17. So our states or phases of matter, we did talk about these with our unit on matter. So if we want to point out once again that we have our solids are over here. They are definite shape, definite volume. They do not conform to its container or take on the shape of its container. When we go left to right, we can make a liquid. However, if we cool it down, it would solidify or freeze. And then we have our liquids here. Liquids have indefinite shape. They have definite volume. So the volume of the liquid will not change based on its container, but its shape will. It does conform to the shape of the container. So as we heat up, we evaporate. And then as we cool down, we freeze or solidify. And if for some reason we're not going to jump anywhere else, he's kind of our middleman. And then we have our last guy here. We have gas, and he has indefinite shape, indefinite volume, meaning he will take on the shape and the total space of the container it's put in, so it fills the container. If we cool him down just a little bit, he'll condense. And if we cool him very rapidly, we could actually have deposition. So we can actually get to the point, like if we hang our clothes out on the line, it will freeze, but then the sun comes out and then we can actually get sublimation going this way. So whenever we're going from solid straight to a gas, we get sublimation. And we go from gas to a solid, we get deposition. And sometimes I think of that as the frost in the morning, and when it rains and it hits your windshield, it can freeze up very quickly, or you spray it with windshield wiper fluid that doesn't have antifreeze solution in it. It could freeze quickly to your windshield, so it goes straight. You could have vapors from the air just depositing on there, or you could have liquids freezing to your windshield. So it's kind of hard to figure out why the liquids are there, if they actually went from gas to liquid to solid, or if they just went from gas to solid. So there are some different things that can happen there with your windshields. But I often think of frost as being sublimation. We have the moisture from, or deposition, sorry, we have the moisture from the air depositing on our windows and creeping up, making those beautiful crystals. So that concludes our video for classifications of matter. We had the states or phases of matter, metals, nonmetals, and metalloids, periods going left to right, and families going from top to bottom with similarities.